said the second level of abstraction, or the higher level of abstraction, is physical contradictions, where we say that any technical contradiction exists because of an underlying physical contradiction. What does a physical contradiction mean? Physical contradiction means that there is some object which is expected to exhibit two independent and two different properties of the same parameter. For example, I may say that what do you say? The chain of a bicycle, it needs to be strong, hard, but it also needs to be flexible. Now we're talking about the same object, the chain of the bicycle, but I want it to be hard and I want it to be flexible also. Now these appear to be contradictions on the same object. I want it to be hard. I want it to be not to be flexible, but I want it to be flexible also. And such contradictions, when we zero them down onto one component of the entire system, are called as physical contradictions. Okay. And he then said that, okay, we will use separation principles to solve physical contradictions. Now, don't worry. I know this might appear like Greek and Latin to you, but I just want to give you an example that the next level of abstraction again would involve inventive principles, but now organized in a different manner. In the technical contradiction matrix, we had the inventive principles organized in a 39 cross 39 matrix. In this level of abstraction, those inventive principles are organized in just 4 or 5 categories. How to separate these opposing requirements in space, time, system, subsystem level, relationship, direction, and so on. So from a 39 cross 39 matrix, we've reduced the solution set to just 5 boxes. And we use inventive principles from these 5 boxes now. Let's look at an example of separation in time over here. I want to build houses on snow. So if you need to build houses on snow, you need to, dig logs of wood into the snow, into frozen soil, and then build houses on those logs. Do you know of this method of making houses in snow? Have you read it somewhere, studied it somewhere? Do you know about it, seen it somewhere? Or it's all alien to you yet?
Not seen, sir.
Okay.
So, sir, this is not no.
Okay. Because the soil is frozen. So see, in India, if you want to make houses, what do? You simply dig the soil, you make the basement, you make the foundation, and you start building the house. Am I right? That is not possible in frozen in places where you have frozen soil. So what you do is you actually dig. You do not dig. You actually just bore and install these logs into soil. On these logs, then you use them as pillars, and then you build the house over them. Okay. So because you cannot you cannot make a foundation like you do in regular soil, you have to use these, you have to bore these logs into soil and use them as pillars. Houseboats you may have seen. Houseboats name these piers that you have along lakes where boats would come and you would jump onto the boats and all that. So those are also done like this. You bore logs into that wet soil, the soil of the lake, and you build those piers above them. You've seen, at least that you must have seen, even if not the snow stuff.
Yes, sir. Yes, sir.
So now what you want is that you want to bore fast. So you want the tip to be pointed, because like a pencil, if I use a pointed pencil to make a hole in some place, I will do it faster. However, if I do that, what happens? My stability of the system, stability of those pillars reduces. So what is done is we separate the requirements in time. We say that, okay, when I am boring, I will have a pointed tip. But this tip actually has an explosive inside it. I will blow the explosive away. I will blow this dynamite away once I have reached the depth that I require. So what happens? The head of the log becomes blunt now. It was sharp when you wanted to bore, but it is blunt when you wanted that stability. So this is the application of the separation and time principle, and the inventive principle that was used was nested dolls over here. Okay. Similarly, separation in relationship. Do you guys drive? How many of you know drive? Like, is there anyone who does not know, or at least has not driven a car sitting in the front on the front seat? Anyone who has not done that, driven a car sitting on a front seat? Or you may not be driving yourself, but at least as a rider, you will be sitting on the front seat. All of you have done that. So if you do that, and if you've driven on nights where there was two-way traffic on the road, have you experienced that the cars that are coming from the opposite side, they kind of glare into your eyes?
Yes.
Yes.
And you're not able to
Yes,
see the road clearly. So what do you say? Okay, go to low beam. What happens when you go to low beam? You're not putting a glare into the other driver's eyes. But what happens? Because you're on low beam, now you cannot drive very fast. Because what happens? You're not able to see far away, and you may actually cause an accident to a pedestrian or an animal who's crossing the road. It happens. So what do you want? You want low beam and high beam to
Yes.
coexist. You want to be able to see any pedestrian or any animal crossing the street, but you do not want to put a glare into the other driver's eye also. You want both. So what is done is, this was again a patented solution. There were two beams. The infrared beam was high beam, and the visible range beam was low beam. So the visible beam, range beam would tell anyone, be it pedestrians, be it animals, or be it the other drivers, that there is a car coming from this side. And you see the dashboard of this car. Over here, you are able to see the pedestrians and animals that are right up there, so that you can slow down and let them cross. So this is separation in relation. So for me, I'm able to see the pedestrians also, and I'm not even putting a glare in the other driver's eye. And the inventive principle that we are using over here is phase change, not just phase change, color change.